Hello. Today, we're going to continue our discussion on orbitals and orbital diagrams and bring that to electron configurations. Now, with orbitals, as you can imagine, it's a little complicated to explain all those electrons hanging out in that space, and then there being another orbital, and then there's a different shaped one, and all of that. Again, we're going to do that in another video as well. But I wanted to jump to one of the ways which we can kind of think of it as a shortcut, and that's electron configuration. So instead of describing all those layers and levels and all that, we can use an electron configuration to say this is where we believe the electrons are. Because the electrons, again, too small, too fast, too random. You are not telling me where these matchstick tips are inside this egg, ever. Same reason you can't pluck a fly out of the air. Too small, too fast, too random. And that on top of the fact that electrons hate each other because they repel, bad news. So for example, looking at the coding, I want to figure out sodium, vanadium, and carbon. Well, we first need to look at kind of where they are. So I'm looking at sodium, and I'm noticing that it's in the 3s spot. It's in that first area. We call that 3s1. Vanadium is in the 3d. It's in that 1, 2, third. Sorry about that. So we call that 3d3. Whereas carbon is in the second spot here in the 2p2 orbital, which I always joke with my students is dos pickups. If you know, you know. Dos pickups. Those of you who know. And the reason I always kind of think of that first is that's normally what students struggle with. Where is the stopping point? In terms of everything else, your goal is to talk about every single electron until that element. That's the magic of an electron configuration. So let's look at that a little bit. So looking at that, we have sodium, vanadium, and then carbon down here. Let's do sodium first. So our goal is to describe all of the electrons before sodium. Because again, we know the ending point. We have to summarize everything else. I think of it kind of like a little road or a book. You have to go down the street, and you're going to go through different streets. 1S is a different street than 2S. 2P is a different street. And these are like the houses. Or the page numbers, if you want to think of it like a book. You need to summarize. So with 1S at the beginning, there are 2 of them. 2S, there are 2 of those. 2P, there are 6 of those we go past. 1, 2, 3, 4, 5, 6. And we're stopping here on 3S. And you'll notice that those are the same. With this, vanadium, I'm going to copy and paste this because, as you can see, it's going to be the same. For the 1x, 2, 2s2, 2p6, 3s2, we're going to keep going. 3p6, 4s2, 3d3. I'm going to apologize for my on that. That's the electron configuration for vanadium. Sorry if it's a little hard to see. Let's try it a bit here. Carbon is a little bit easier. Carbon, again, 1s, 2, 2s, 2, 2p. Again, I'm just describing everything until that point. The top exponents are a way we can check. 2 plus 2 plus 6 plus 1 is 11. Sodium's element 11. 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 3 is 23. Is 23. And 2 plus 2 plus 2 is 6. And that's carbon. I'm going to do a separate video on how to do this even shorter in a few seconds.